So first question from our independent practice is in the subject of art, Marie has a small copy of Rene Magritte's famous painting, The Schoolmaster. Her copy has dimensions 2 inches by 1.5 inches. The scale of the copy is 1 inch is equal to, or scales to 40 centimeters. Find the dimensions of the original painting for part A. Well, let's see. I'll bring this over here. And let's write down our scale down first. The scale is 1 inch is 40 centimeters. So let's go with the first dimension, 2 inches. So notice I have inches on the top and centimeters on the bottom. So that is equal to make a proportion, that would be 2 inches. And we're trying to find out how many centimeters that would be. To find that out, we would cross multiply. And that is 40 times 2, which is 80, equals 1 times x. 1 times x is just x. So that's 80. So it would be 80 centimeters. And then I will, let's see, I'll move this over a little bit more. And the other one's 1.5 inches. So let me go ahead and say that we use the same scale. 1 inch is 40 centimeters, but now instead of 2, it's going to be 1.5 inches is how many centimeters. And 40 times 1.5, well, that would be 60, I believe. So when you cross multiply these, you would get 60. And then cross multiply these, and you get x. So 60 is x. So the other one right here, 80 by 60 centimeters. Okay, find the area. Well, that would be 80 times 60. And to do that quickly, I would just have to do 8 times 6 is 48, and then add those 2 zeros to it. So it'd be 448 with 2 zeros, and that's done in centimeters. But when we're talking about area, we're talking about square centimeters. So you got to put a little 2 right there. Okay, since 1 inch is 2.54 centimeters, find the dimensions of the original painting in inches. What I would have to do is I would have to take 80 divided by 2.54, and I'd have to take 60 divided by 2.54, and that is about 31.5, and that would be inches, and this is about 23.6 inches. Okay, find the area of the original painting in inches. Well, that would be 31.5 times 23.6. And let's see, I'm going to put it in a calculator here. We have 31.5 times 23.6, 743. That's 743.4 square inches. So that was written as inches squared. Great. Next, a game room has a floor that is 120 feet by 75 feet, and a scale drawing of the floor and grid paper uses a scale of 1 unit is 5 feet. What are the dimensions of the scale drawing? So what I would do is I'll move over to the side here and use that scale. So I have 1 unit is 5 feet. So one of them is 120 feet. So that would be 120 feet. Notice I put the 120 in the denominator because we're talking about feet, and anything with feet is going to go in the denominator, and our units are going to go in the numerator. So that's going to be solving for x on the numerator. Cross multiplying means I get 5x equals 120, and I have to divide both sides by 5, so I can solve for x. And that would be, what, 5 goes into 12 one time, and there's 2 left over, so it'd be 14. Whoops, wait. Just kidding. That was 24, right? 5 goes into 12 two times. That's going to be 24. So there's one of the dimensions. And then the other one's going to be, what? I'll go quick. 1 over 5 is equal to, and we want to find what the other one's, I could see it peeking out right over there, 75 feet right there. So it's going to be x over 75. So we have x over 75. So when I cross multiply, I would have 5x equals 75. I divide both sides by 5 again. And that would be, I believe that is 15. So it looks like that finishes off the problem. It's 24 and 15. So it'd be 24 units. Okay. By 15 units. Okay. Next, multiple representations. The length of a table is 6 feet. On a scale drawing, the length is 2 inches. Write 3 possible scales for the drawing. Well, one of them is given to us. It would be 2 inches is 6 feet. Another one, well, let's take half of these. 1 inch is 3 feet. And then I could take, I could double it, right? I could take 4 inches is, and when I say double, I'm thinking of doubling this right here. 4 inches is 12 feet. There's a lot of different options. 12 feet. Okay, a scale for a drawing is 10 centimeters is 1 millimeter. Which is larger, the actual object or the scale? Well, let's see. We're going from 10 to that. The drawing is larger. So the drawing is larger, and because 10 centimeters is greater than 1 millimeter. See, we're going from a bigger thing to a smaller thing, so the drawing is larger. Okay. And then here we have the scale model of a building is 5.4 feet tall. If the original building is 810 meters tall, what is the scale used to make the model? Well, what we could do is we could see that we have 5.4 feet and 810 meters. And I mean, I guess we could use that as the scale. 5.4 feet is 810 meters, but we could divide both of these by 5.4, and that would probably be a little bit better. So this then is 1 foot, and it turns out 810 divided by 5.4 is 150 meters. So this would be probably the better answer is, I'll put it in blue, 1 foot is 150 meters. If the model is made out of tiny bricks, each measuring 0.4 inch in height, how many bricks tall is the model? So what you'd have to do is we'd have to see first, it's 5.4 feet tall. We're going to use that, and we're going to multiply that by 12, right? So to get how many inches we got. So 5.4 times 12, what that's 8, 10, 4, 5, 8, 4, 6, 64.8 inches. Okay, and we would have to take the 64.8 and divide it by 0.4. And when we do that, because that's how many 0.4 inch, how many bricks fit into that height, and that would be 162 bricks. There you go. So in this problem, you've been asked to build a scale model of your school out of toothpicks. Imagine your school is 30 feet tall, your scale is 1 foot, equates to 1.26 centimeters. If a toothpick is 6.3 centimeters tall, how many toothpicks tall will your model be? So I'm thinking first, I'm going to use my scale, and I'm going to move this stuff over here, and I'm going to use the scale of 1 foot is 1.26 centimeters. And so if we have 30 feet, how many centimeters will that be? Well, what we would have to do is we'd have to multiply 30 times 1.26. I have a calculator here, so 30 times 1.26 is 37.8. So that would be 37.8 is equal to this 1 times x, which is really just x. Okay, now that means it's going to be 37.8 centimeters. Okay, so that's how tall it is. It's 37.8 centimeters. Okay, so if each toothpick is 6.3 tall, how many toothpicks tall will your model be? Well, what we would do is we would take the 37.8. Oh, I didn't mean to do that. I want this. 37.8 and divided by 6.3. And 37.8 divided by 6.3 is exactly 6. So that would be 6 toothpicks tall. So the next one, your mother's out of toothpicks and suggests use cotton swabs instead. You measure them at about 7.6 centimeters tall. How many cotton swabs tall will your model be? Okay, well, we're going to do the same kind of thing as we did before. And we have that 37.8. Oh, I'll put it in my work area. 37.8 divided by, this time, 7.6. And I'll put these little squiggly lines here. So about, and my calculator says it's about 4.97. It's a super long decimal. So we'll say about 5. Okay, oh, cotton swabs. Okay, next. We're going to draw some conclusions here. And right here it says the area of a square floor on a scale drawing is 100 square centimeters, and the scale drawing is 1 centimeter is equal to 2 feet. What is the area of the actual floor? What is the ratio of the area of the drawing to the actual area? Well, let's see. If we have a scale, so this will be for number 12. If we have a scale of 1 centimeter is 2 feet. Okay. And what we got to know is if we have 100 square centimeters, that means, and I'm going to do this off to the side here, if we have 100 square centimeters, what that means is you have a square. What a wonderful square. And if it's 100 square centimeters, that means each side is 10 centimeters. That's supposed to be an M right there. Square centimeters. Because 10 times 10 is 100. And that's how you get your area. So if we have each one is 10, then that means that we would have, this would be, so each side is 10 centimeters. Oh, goodness gracious, can I just write an M? And So that means if I have to multiply this by 10, this one gets multiplied by 10, and that would be 20 feet. So this is the model, but in the actual, it would be a 20 foot by 20 foot square, and 20 times 20 is 400, and that would be 400 square feet. So that would be our answer for this one. Be what is the area of the actual floor? It would be 400 square feet. And then we were asked, what is the ratio, right? What is the ratio of the area in the drawing to the actual area? Well, the area in the drawing, let's bring this over here. The area in the drawing, we're looking at 100 is that to 400, or 1 to 4. One square centimeter to 4 square centimeters, because I'm taking 100 divided by 400. So the scale, I'll write scale is 1 square centimeter, I'll do it like that, is 4 square feet. Oops, square feet. So square feet. Okay. Describe how to redraw a scale drawing with a new scale. So first, I think what you need to do is you need to decide on the new scale. So when you're going to redraw it, well, what is your new scale? Then find the ratio. The ratio of from the old scale to the new scale, and then make the drawing. Okay, so for example, 1 to 3. So that could be our new, could be the new ratio. And you would redraw the dimensions at 3 times the original size. You would redraw the dimensions to 3 times the original size. Okay. And let's go with our last one, number 14. The scale drawing of a room is drawn on a grid that represents a 1/4 inch grid paper. Scale is 1/4 inch, goes to 4 feet. Redraw the scale drawing of the same room using a different scale. What scale did you use? What is the length and width of the actual room? What is the area of the actual room? Okay. So my new scale, instead of 1/4 inch goes to 4 feet, we can call it 1/4 inch goes to 8 feet. And now, so that's my new scale. But what is the, now going back to our original right here, 1/4 inch is 4 feet. Each of these 1/4 inch counts as 4 feet. So this is 4 feet, 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 4 feet. How many of those do I have? It looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be, what are the actual length and width? So length equals 40 feet. And then this is 1, 2, 3, 4, 5, 6. and each of those count as 4 feet. And so 4 feet by, oh, I shouldn't do that. I'll do the width. All right, width is equal to 4 times 6, which is 24 feet. And the area is equal to 40 times 24. 40 times 24, which is 960, and that would be square feet. And there you go. All right, so that's what you got to know for the stuff. I hope this has been helpful. Bye.